Investigators are launching a new high-tech search today for a plane that disappeared more than 10 years ago. The Malaysia Airlines flight vanished from radar over the Indian Ocean with 239 people on board. Now, Malaysia's Transport Ministry says a Texas-based marine robotics firm is starting a new deep-sea search for the missing plane.
After 12 long years, ships are back in the southern Indian Ocean, scanning the seafloor for one of the greatest mysteries in aviation history, Malaysia Airlines Flight MH370. Not a massive, sweeping search like before. This time, it's focused, precise, almost like they finally believe they know where to look. And that alone changes everything, because for more than a decade, this plane didn't just disappear from the sky. It disappeared into questions, into theories, into a silence that families, investigators, and the world have never really been able to live with. So, let's walk through what happened, what we actually know, and why this new search might be the closest we've ever come to the truth. Let's go back to the beginning. March 8th, 2014, just after midnight in Kuala Lumpur, flight MH370 rolls down the runway, bound for Beijing. On board are 227 passengers from 14 countries and 12 crew members, business travelers, families, students, people who thought this was just another overnight flight they'd barely remember. For the first 40 minutes, everything is normal. The plane climbs to cruising altitude. Radio calls are routine. The cockpit sounds calm. Then, at 1:19 a.m., the final words come through. "Good night, Malaysian 370. And just like that, the plane stops talking. Its transponder, the system that tells air traffic control where the plane is, goes dark. On civilian radar, MH370 simply vanishes. But military radar tells a different story. Instead of continuing toward Beijing, the jet makes a sharp turn. It crosses back over Malaysia, flies out over the Andaman Sea. Then, one by one, even those radar contacts fade. To the world, the plane is gone. But it wasn't gone yet. Hidden inside the aircraft is a small system called a satellite data unit. It's not meant to track planes. It's just designed to check in with a satellite every hour, like a quiet, "I'm still here." And for 6 hours, after the plane vanished from radar, those signals kept coming. Ping, ping, ping. By measuring how long each signal took to reach the satellite, analysts drew a giant arc across the Earth, a curved line stretching through the southern Indian Ocean. That line became famous, the seventh arc. Somewhere along it, investigators believe the plane ran out of fuel and fell into the sea. But here's the problem. That arc stretches across thousands of kilometers of some of the most hostile ocean on Earth. And for years, all anyone really had was a line on a map. Theories exploded. Some said it was a catastrophic failure. Others believed the passengers lost oxygen and the plane flew on as a ghost flight. Some pointed at the captain, noting a flight simulator at his home that had a path ending in the southern Indian Ocean. But without the wreckage, nothing could be proven. Then, more than a year later, the ocean spoke. July 2015. A piece of wreckage washes up on a beach on Reunion Island, off the coast of Africa. It's a flaperon part of a wing used to control the plane's roll. Inside it, investigators find a serial number. It matches MH370. That moment changes everything. The plane didn't land somewhere. It didn't disappear into thin air. It went into the ocean. Over time, more pieces appear in Mozambique, Tanzania, Madagascar, South Africa. Small parts, a piece of engine covering, a bit of cabin interior, fragments of seats, not hundreds of pieces, less than 30. And that tells investigators something chilling. If the plane had shattered on the surface, debris would be everywhere. Instead, the limited number of fragments suggests the aircraft likely hit the water mostly intact and sank. But the debris does more than confirm the crash. It becomes a map. Scientists start modeling ocean currents, and the Indian Ocean is different from almost anywhere else on Earth. Its currents don't flow in neat, predictable paths. They shift with seasons, with wind, with temperature. A piece of debris can drift in slow circles for months, then suddenly get pulled into a fast-moving current and travel thousands of kilometers. Even tiny changes in where the plane went down could mean the difference between wreckage washing up in Africa or never being found at all. Researchers even study the barnacles growing on the flaperon. The type and size tell them the water temperature it floated through. Colder southern waters first, then warmer currents heading north. All of it points back to the same place, the southern end of the seventh arc. So they search. Between 2014 and 2018, more than $150 million is spent scanning the ocean floor. Ships drag sonar behind them for years, and they find nothing. No fuselage, no wings, no engines. To the outside world, it looks like failure. But the truth is, the ocean didn't make this fair. The search zone sits in a region sailors call the Roaring Forties. Relentless winds, towering waves, some of the roughest seas on the planet. And beneath the surface, it's even worse. underwater mountains, deep trenches, sharp ridges, volcanic formations. In some places, the seabed drops nearly 7 kilometers down. The sonar they used was towed behind ships on cables miles long. That creates a problem. If the wreckage is behind a ridge, the sonar can't see it. It casts a shadow, just like light over a mountain. So it's entirely possible search vessels passed right over MH370 and never knew it. There was another assumption too. Most models believed the plane flew straight on autopilot until it ran out of fuel. But if someone made even a small turn at the end, just a few minutes of manual control, the crash site could shift by tens of miles. In terrain like this, that's the difference between being visible and being hidden forever. So what changed? Why search again now? 2 things: data and robots. Let's start with the data. Researchers began looking at something no one ever thought would matter: ham radio signals. There's a global network called WSPR, Weak Signal Propagation Reporter. It's used by hobbyists to bounce tiny radio signals across the planet. But here's the strange part. When a massive metal object, like a Boeing 777, passes through those invisible radio paths, it can slightly disturb them, like walking through a spider web you can't see. By analyzing old WSPR logs from the night MH370 disappeared, scientists found hundreds of these tiny disturbances. When they line them up, they form a rough flight path. Not perfect, not precise, but enough to suggest the plane may have flown farther south than earlier models believed. Now, this is controversial. Critics say WSPR was never designed to track aircraft, weather, atmospheric changes. Even other planes could create similar signals. Supporters say the strength isn't in one data point. It's in thousands lining up along the same path. So instead of replacing the old evidence, they layer it on top. Satellite pings, debris, drift, radar data, and now radio signal modeling. Together, they narrow the search zone, and that's where the robots come in. This time, Ocean Infinity isn't dragging sonar behind a ship. They're releasing autonomous underwater vehicles, robotic submarines that swim just above the seabed. They move in coordinated patterns. They dive deep into trenches. They slip around ridges. And their sonar doesn't just create fuzzy outlines. It creates images detailed enough to spot the shape of a wing or the curve of an engine casing. Some of them even use onboard AI to flag anything that looks man-made instead of natural rock. It's not about searching more ocean. It's about searching smarter. There's another twist. Ocean Infinity is working under a no-find, no-fee deal. If they don't locate the wreckage or the flight recorders, they don't get paid. If they do, they could receive up to $70 million. That changes the entire mindset of the mission. Every scan, every dive, every decision has weight. They're not just exploring, they're hunting. So what happens if they find it? First, remotely operated vehicles would be sent down to photograph the wreck. The condition of the plane alone could answer huge questions. If it's mostly intact, it suggests a controlled descent. If it's scattered across miles of seafloor, it points to a high-speed impact. But the real prize is something smaller. 2 orange boxes, the flight data recorder and the cockpit voice recorder. Even after 12 years, there's a chance the memory inside still works. One tells you what the plane was doing, the other tells you what was being said. And between them, the last chapter of MH370 could finally be written. But for the families, this isn't really about data. It never has been. For more than a decade, they've lived in a strange kind of limbo. No confirmed crash site, no final report that answers why, no place to go and grieve. Many have described it as an open wound, because without certainty, the story never truly ends. Finding the wreckage wouldn't erase the loss, but it would end the waiting. Right now, Ocean Infinity's ship is working in a narrow weather window, in one of the most remote places on Earth. They're focusing on a tight stretch of the 7th arc, not because they're guessing, but because, for the first time, multiple lines of evidence are pointing to the same patch of ocean. And maybe that's the real difference this time. Not hope, not theory, but convergence. After 12 years, the search for MH370 isn't just back on. It's closer than it's ever been. And somewhere, deep beneath the waves, the answer may already be waiting. Subscribe to Hidden Latitude for the latest updates about the new search. Thanks for watching.